Welcome to this live class. I'm so delighted to be with you. In today's video, I want to look at our calculation of what empirical what molecular formula, and this one is going to be under what organic what chemistry. So you're going to pay close attention to what I'm going to do here. You're going to see questions like this. So make sure you have your pen, your notebook. If this video is really helpful, please always give it a like so that I can know that somebody's there actually what following this what video. Now, if you have friends that can join this live class, so you can simply what send link to them that they should what join this class too. So pay close attention here. Here I want to look at the question. 0.029 gram of an organic compound gave 0.0558 gram of CO2 and 0.024 gram for H2 on combustion. The molecular mass of the compound as determined by experiment is what 88. So you calculate the following: A, the mass of elements in the word compound. B, the percentage composition of each of the elements that what has to do for. C, the empirical formula. D, the molecular formula of what of the compound. You can see how tough this question look like. So I want to use this question. I want to use this one here to learn so many calculations. Now, before we do that, before we start solving it here, now whenever organic compound undergo combustion, I want to say on combustion, that is the organic chemistry we don't know. We have what oxygen to produce what CO2 plus what H2O. Whenever you want undergo S, which is organic compound, undergo what combustion, you only produce CO2, but you don't know the organic compound. Look at that. So the mass of what this CO2 was given to us, and mass of what water was given to us. So it's from the mass of what CO2 and what mass of water given to us. That what I'm going to use in the what calculation. So mass of the organic compound, mass of the organic compound, which is the X. Look at that. Mass of X is going to be 0.029 gram. Then mass of what CO2 is what gave me what 0.058 what gram. Then mass of what H2O is what is 0.024 gram. So these are all the stuff given to us. You get these are all the stuff given to us. Now you want to know the numbers of elements in that compound here. Of course, the compound will contain what carbon and what hydrogen. You get so you must calculate what the mass of what carbon and hydrogen. Then if you sum them together and it equates this one here, it means that nothing else is present because when organic compound undergo combustion, there are a possibility that it can contain carbon, hydrogen, and any other what element. Do you get that? But from here, no other stuff was given, just CO2 and what H2. So there is a possibility that it may contain carbon and what hydrogen, and also what oxygen. Yeah. So we want to calculate what the mass of carbon. We want to calculate what the mass of carbon in what is CO2, and mass of hydrogen in what H2O. How do we do that? We're going to be mass of what element equals to what the atomic mass what mass times what n or what molar mass of what compound times what mass of what compound. Mass of what compound. So mass of the element equals to what the atomic mass of the element times n. This n means what the numbers of atom present. Do you get the numbers of what atom what present? So now let's look at this one here. Calculating what? So let's look at what? Calculating the mass of carbon in what CO2. So you can say calculating mass of C in what CO2, right? So when you do that here, so that is the first one to do here. So calculating mass of carbon in what in CO2. So the first one to do here is to calculate what the molar mass of what CO2. Molar mass of what CO2 is equal to what? It's going to be the atomic mass of carbon is 12 times 1 because the mass of atom of carbon is what is 1 plus 16 times 2 Now F is going to be what 44 what gram per mole. You get? So if I shall apply the formula now, yeah, mass of carbon in what CO2 is equals to what? Now the atomic mass of carbon is what? Is 12 times the mass of atom of carbon is what? Is 1. Do you get that? Gram per mole over what? 44 gram per mole. Do you get that? Times now what is the mass of CO2? The mass of CO2 here is going to be 0.058 gram. Get that? Gram per mole cancel gram per mole, right? 12 times 1 is going to give me 12 divided by 44 divided by this. So you are going to have 0.01581 gram of what? C. So that is my mass of carbon here is what? My mass of carbon here is what? 0.01581. So go to wise art. So yeah, we just put this on here. Carbon equals what? 0.01581 gram. So because I'm going to make it on this one here. H in what? H2O. Mass of H in what? In H2O. So I'm going to do that. So the molar mass of H2O will be what? 1 times 2 plus what? 16 times 1. Going to give me what? 18 gram per mole. Do you get that? So mass of H in what? H2O. So the atomic mass of hydrogen is 1 times 2 because the mass of hydrogen is what? Is 2 gram per mole over what? 18 gram per mole times. Now, what is the molar mass of water? Here we have 0.024 gram. Look at that. So if you put your calculator here, you have 0.0026 gram of what? Hydrogen. Do you see that? So here, mass of hydrogen here, hydrogen is going to give what? 0.0026 gram. Oh, do you get that? So this is what you are going to what to get. Mass of what? Hydrogen plus what? Mass of what? Mass of what? Carbon, sorry. Mass of carbon plus what? Mass of hydrogen. It's equals to what? Here we have 0.0158, right? 1 plus 0.0026 gram. 0.0184. 0.0184 gram. So this is what the mass of what? Carbon and hydrogen, which does not equate to the mass of this guy here. That mass of oxygen, that is this compound here contain carbon, hydrogen, and one other element. So whenever you add the two mass of carbon and what mass of hydrogen, and it does not equate to what mass of what of the what compound, you know that oxygen is what is present. Do you get that? So you can say mass of oxygen equals to what? The mass of what? X, which is what the organic compound, minus mass of what? Carbon plus what? Mass of what? Hydrogen. Do you get that? So we're now going to be what? Mass of X is what? 0.029. 0.029 gram. Minus, now remember when I 2 of them, we have 0.0184 gram. 0.106 gram. I can just say what mass of what oxygen go to do what 0.0106 gram. Mass of carbon equals to what? 0.01581 gram, right? I say mass of what? Hydrogen is equals to what? 0.0026 gram. Here we can say mass of what? Oxygen equals to what? 0.0106 gram. Remember, this one is the A. So we are done with A. B says she will calculate what? The percentage composition. Do that. So percentage composition equals to what? Mass of what element? Well, what mass? So yeah, mass of what compound? Then I'm talking about the organic compound now times what? 100 by what? 1. Wow. So we are looking at what B. Percentage was composition. Percentage was composition. Remember, now my mass of element, which was mass of what? X. Can you remember what is it? So my mass of X given to me was 0.029. 0.029 gram. Do you get that? So we want to look for what the percentage composition for what each of what of the element now. So can I say percentage of C, the first one here. We want to do what mass of the element here, which is 0.0158. 0.0158 what gram over X is what 0.29. 0.029 gram times 100 over what? Over 1. Do you see that? So this will cancel out this guy here. So punch your calculator 54.483%. Now it's advisable to what? Leave the answer in 3 decimal points for accuracy. Do you get that? Don't leave the answer in 1 decimal point or 2 decimal points. Leave the one in 3 decimal what points. So we are done for what? For carbon. Now let's do the same for what? For hydrogen. So we're going to be the same here. The mass of what hydrogen is going to be 0.0026 gram over 0.029 gram times 100 over what? 8.966%. Remember, I told you that only the answer what in 3 decimal points. So you have percentage of what? Oxygen now. Same thing here, mass of oxygen, which is going to give me 0.0106. Percentage of oxygen now, which is going to be the mass of what? The element is 0.01106 gram over mass of the element, which is going to be 0.029 gram times what? 100 over what? 1. So what happened here? 36.552%. This is here. So yeah, my percentage of carbon now is this one here. My percentage of what oxygen of hydrogen is this. My percentage of what oxygen is this one. So the next one to do here is the what we have calculated A and what B. A says she will calculate what the mass of what of each of the element present. B says she will calculate what the percentage what composition. Now the C says she will calculate what the empirical what formula. And what I want to tell you is that you can either use the percentage composition by mass. Here called mass composition. Do you get that? Mass what? Composition. If you sum everything here, you're going to give me what? 100. This plus is going to give me what? 100. So what you want to do here is what? You can either use the mass of what? Of the compound or the percentage by mass of what? Of the the mass of what? Of the elements or the percentage composition of what? Each of what? Of the elements. So we want to look at it very well. So let's look at what the empirical formula. So now let's look at what. So we are going to use the percentage composition to what calculate what the empirical formula. So carbon is equals what 54.483%. Hydrogen is equals to what 8.966%. Then oxygen is what 36.552%. Okay, the first one to do is what calculate what the mole of each of what of the elements. Do that. After that, you have to look for the mole ratio. How do you look for the mole ratio? By dividing by what? By the simplest what mole. From there, you now know what to do. So I'm going to explain to you. So mole of what carbon is equals to what. Now remember, I told you that you can either use this one or you can use the mass. So here you go now what a mass composition. So remember, mole equals to what mass or what molar mass. So here we are taking as what as mass going to be 54.483 gram over what 12 gram per what per mole, right? So you have mole of what hydrogen is equals to what 8.966 gram over what 1 gram, 1 gram per mole. Then here we have mole of what also equals to what we have 36.552 gram over what 16 gram per mole. So what you want to do here is what use your calculator to get your answer. Mole. You get. So there was my various mode. The next is to look for what the mole ratio. Now when you have the mole ratio, I want the word divide through by what by the simplest mode. Here we have 4.54025 mole. Here we have 8.966, and here we have 2.2845 mole. You get. So this one is simplest mode. So mole ratio. So going to be carbon ratio, hydrogen ratio, what oxygen. So going to be what you have 4.54025 over what 2.2845 2.2845 ratio, right? Remember there is mole. Let's ignore the mole. So you have 8.966 over 2.2845 ratio. Here we have 2.2845 brought 2.2845. So now remember, I need to be careful when you are doing this stuff here. So let's say I want answer 4.54025 divided by 2.2845. So we're going to these are going to give me two ratio. Look at this one here. Here we have 8.996 divided by 2.2845. You're going to be what 4 ratio 1. You get. So my empirical formula here, empirical formula is equals to what? Carbon, that is the number of carbon here is going to be what? 2. H is going to be 4. Also is going to be what? 1. So, but there are times when you have fraction on that. We are not going to talk about this one here. In our next class, we are going to look at those ones. Or in my next video about this topic here, I'll look at that one here. But fortunately for us, they gave us direct what number C to H for O1. So next thing is to calculate what the molecular formula. Remember, the empirical formula is what is the simplest ratio. The simplest ratio. One molecular formula is what is the actual what ratio. So the calculating molecular formula. How do you calculate molecular formula here? So here we have empirical formula. The N equals what? Molar mass of compound. Remember, the compound gave us 88 as what molar mass. Let's check again. What is molar mass of the compound given to us? Is what 88. So we're going to bring C to H for O, N equals what 88. So we want to look for what the total molar mass of this guy here. So here we have going to be 12 times 2, right? Plus 1 times 4 plus 16 times 1 equals what 88. Hope you are following. So remember here is what N. So you want to look for what numbers of N here. So the whole of this one here is going to give me what 12. So here we have 12 times 2. Here we have what 20 what 4, right? Here we have what 24 plus 4 plus what 16 give me what 80 what 8. So we're going to be what 44 what N equals to what 88. So making N instead of formula here, N equals to what 88 over what 44. Going to give me what 2. So then my N is going to be what 2. So what will that be my what molecular formula. Remember, empirical formula C2H4O. Because my 2 is so because my n is 2 now, it's going to be 2. So what does it mean? 2 times 2 give me 4. 2 times 4 give me 8. 2 times 1 give me what? 2. So my molecular formula that would be C for H8O2. This is what my molecular formula. This is what empirical formula. This is what molecular formula. This is called simplest ratio. This is called what? Ashra what? Ratio. So these are how to solve molecular formula and empirical formula. Now when it comes to what combustion of what hydrocarbons. So you really want to pay combustion of what organic compound. Sorry, this is how you will calculate what molecular formula and empirical formula. Molecular formula and empirical. This is how you can calculate what molecular formula and empirical formula of organic compound. Do you get that? So when you combust what organic compound. So go to the video again. I'll see you there. So if this video is helpful, please leave a comment there. I don't want this video to be too lengthy. I'll see you next time. Thanks.